Hello, and welcome to another Math VMK from www.maticknows.com. If you find my tutorials helpful and you'd like to support my website, please go to www.matickknows.com and click on any of the ads found on the side, or click on the PayPal icon. In this VMK, I'll be showing you how to calculate the normal in 3D space. So, how to find the normal? You usually start with 3 points defining a surface. In this diagram here, I've given you 3 points, P1, P2, and P3. And if we were just to draw some arbitrary shape by connecting those 3 points, we should get a triangle. First thing you need to find are 2 vectors that are on this surface. And you can do this by using the 3 points that were originally given to you. So vector 1, you get by taking point 3 and subtracting point 2 from it. And you do this component by component. So you subtract the x components, the y components, and the z components. And this gives you v1x, v1y, and v1z. You then get a second vector, I call it v2, by taking p1 and subtracting p2 from it. And again, you repeat the same thing doing component by component subtraction. So you get v2x, v2y, and v2z. And on the diagram here, you see by calculating these 2 vectors, you're actually getting the direction from p2 to p3, that gives you v1, and from p2 to p1, that gives you v2. Now it's very important the order that you do this in. Don't switch v1 and v2, or else you'll end up calculating the wrong normal. For us, we have P1 down here, P2 down here, and P3 up here. So for clockwise rotations from P1, P2, P3, we define vector 1 to go from P2 to P3, and vector 2 to go from P2 to P1. This is important in the next step, because in the next step, we're going to be calculating the normal. And the way we do that is we need to take v1 and cross it with v2. So we use the cross product rule. This gives us the normal. The normal itself will not be a unit normal until we normalize. By taking the cross product between v1 and v2, we get the following. We get the x component of the normal, the y component, and the z component. And the values of each of these 3 components are shown here. So the x component of the normal is equal to v1y times v2z minus v1z times v2y. The y component of the normal is equal to v2x times v1z minus v2z times v1x. The last component of the normal is equal to v1x times v2y minus v1y times v2x. This formula here for the cross product is a well-known mathematical equation. All you really need to know is the pattern that you multiply these 2 vectors together to give you the cross product. Once you have n, you need to normalize it to get a unit normal. And to do that, we take the value of n and divide it by the magnitude of n. The magnitude of n is calculated by taking the square root of each of the components squared and added together. So we take nx squared, add it to ny squared, and add that to nz squared. That total we square root, and that gives us the magnitude. Now remember, there's 2 normals to a face. The first normal we calculated was coming out of the face. The other normal goes into the face on the back side. And you can calculate it by taking v2, crossing it with v1. Or you can take the minus of v1 cross v2. So notice that v1 cross v2 is not equal to v2 cross v1. There's actually a minus sign difference between the 2. So once you have one normal, you can just take the negative of it to get the other normal on the other side. And since we're going counterclockwise, we're always doing v1 cross v2 to get the normal on the front face. If we wanted the normal on the back face, we could either calculate V1 cross V2 and take the minus of it, or just calculate V2 cross V1. Let's say we want to calculate the normal of a surface that is defined by the following 3 points. P1 is -2, -1, 0. P2 is 4, 2, -3. And P3 is -3, 3, and 4. Well, first thing we need to do is calculate the two vectors. So V1 is equal to -7, 1, and 7. And V2 is equal to -6, -3, and 3. Having these two vectors, we can then cross them and normalize to get the following value for our normal. Now let's take a look at the plot in 3D. Here I show you the 3 points. First point, -2, -1, 0. Second point, 4, 2, -3. And the third point, -3, 3, and 4. Calculating everything together, I got the normal, and then I drew the normal here in the middle of the face, just to show you what it looks like. If I were to go and rotate this face now, you can see that the normal is exactly perpendicular to the face. No matter how I look at this face edge on, the normal is always pointing straight out of the face. If I wanted the negative of this normal, then when I look at this face edge on, the normal wouldn't point this way, upward, instead it'd point downward. So that's all you need to do to calculate normals of a three-dimensional face.